Before we get into the example from the last video, there are two things I want to talk about that were going to help us with that example. The first is what we call a regression line. A regression line is basically just a more accurate line of fit. So it's something that's usually going to be calculated either on the computer or on your calculator rather than doing it by hand like you would with a regular line. The correlation coefficient is a number. We use the letter R to represent it, so you might say R equals and then give the number. And it's a number that's between -1 and 1. And basically what that correlation coefficient tells you is what kind of correlation you're going to have in your data. So the closer it is to -1, then the closer to negative correlation it's going to be. If it's around 0, maybe it's like positive 0.2 or negative 0.5, something like that, then it's going to be no correlation. And then if it's close to +1, then it's going to be considered positive correlation. All right, so it's going to be a range. It can be a decimal number, but those are the three main correlations we talk about, so you can see where those range from. Now, the example that we ended on the last video had this set of data, the year people were born, and then the average life expectancy based on the particular year. So what we're going to do is use our graphing calculator in order to make a scatter plot, and then we're going to also use the calculator to calculate the regression line and use that line to predict what the life expectancy would be of someone who's born in 2020. So in this example, if you have a graphing calculator, I can show you individually how to use yours in class, but I'm going to go ahead and use Desmos since most people don't. So you want to go to www.desmos.com, and what you're going to see when you click graph is that it's going to give you this grid, and over on the left side what you can do is hit the plus sign and then click table, and then what's going to do is going to give you an empty table and you can just enter in the data points from that video. So I've got those all listed here, and it wouldn't hurt for you to also try this on your own. All my X values are all the years, the Y's are the average life expectancy, and then what we're going to do is adjust our graph so we can see these points, because obviously here my graph goes from 0 to 10 or 0 to 8, and these are in the 1980s, 1990s, so those are way off of our grid. So to fix that, you're going to hit this little graph settings button in the top right, and where it says x-axis and y-axis, you're going to change the values that are the lowest and the highest. So obviously we don't have any negative years, so we're going to put the lowest year value close to our data table. So I'm going to put 1970. And then we go all the way up to 2006 in our table, so maybe I even put all the way up to 2020 just because that's what we're looking at. And that changes our X value on our graph, and then we're going to do the same for the Y. The lowest in our graph was 73.7 years, so maybe I put 65. And then the highest I'll put 85. And it doesn't really matter what the numbers are as long as when you look at your table you can see all the points you plotted. Notice that they're not an exactly straight line, so this is where that whole concept of line of best fit or regression line would come in handy. And you could do that by hand, but Desmos is nice because it will calculate the most accurate line to fit this data. And to get that line, you're going to type in this equation as I type it, so it'll be y and then 1. And then you're going to type, instead of an equal sign, you're going to type this symbol, because that means it's going to be approximating it. And then we're typing the equation of a line, so mx plus b. So mx1 and then plus b. The reason I put y1 and x1 is because that's the letters that are used in our data table. So notice it's x1 here, y1 here. If you had multiple tables, you'd want to make sure that Desmos knows which table you're pulling the data from. And now we see this purple line, and this is as close as possible to fit the data, and so this would be considered a regression line. What you should see here is that there's some key information that they actually give you in this box once you've typed that in. The first thing that you see is this r squared value. Okay, the r and the r squared value, those tell you how close the line is to the data. So that goes back to our correlation coefficient. Notice that 0.98 and 0.99, those are very, very close to +1. So this is going to have a positive correlation. And by looking at the graph, you should be able to tell. But the closer to 1 it is, the closer the data fits the line. Okay, so you want it, if you're wanting positive correlation, you want it to be as close to 1 as possible. as possible. Okay, so I'm going to go ahead and type that on our screen here. So we found the regression line. We've got that typed in, and for that we found that our R value was 0.99, which means positive correlation. All right. The other thing is we want the equation of the line. So to get that, we look at the M and B values that they give us here at the bottom. M is our slope, B is our y-intercept. So I'm just going to write that in equation form. You don't have to do any work, just write it. Y equals 0.144,102x, because that was our slope, and then plus B, or in this case because it's negative, so minus 211.432. So this right here that I'm about to highlight, or put in blue, that is our equation of our regression line. Okay. And now we can use that equation to predict the life expectancy of someone born in 2020. And obviously those numbers you got from that equation are not very nice. This is why the calculator is so handy, because doing this by hand would be very difficult. You wouldn't get necessarily nice numbers, and it's not always going to be nice whole numbers in general. So Desmos is very useful. So if we want to predict the life expectancy of someone in 2020, remember our year is the X value, and so all we have to do is plug X in. We'd have Y equals 0.144102 times the year 2020, because that's what we're looking for, and then minus 211.432. And then you could just go to your calculator and type this in, and when you do that, let's see, minus 211.432, you get that the average life expectancy would be 79.7. And so that would be our final answer. And you could always check that. You could go back to Desmos, type in 2020 into your data table, and see if your data hits very close to your line or is exactly on your line, and that's what you're looking for. Okay? So if you have any questions about how to get the regression line or how to predict using the equation that was given to you, let me know. But that's it for this section. Thank you.